Kaspersky Labs, and today we are going to talk about supply chain security and everything related to that. In principle, let's begin. This is a standard slide with a link. Join the group, join the community, ask your questions, get the answers. So, once again, I'm Dmitry Shmoilov. I deal with security in Kaspersky Labs. And I can tell you while you are reading that for good questions we're going to give you gifts and some other merch items. Good questions are welcome, bad questions are not. Well, what are we going to talk about? First of all, what is supply chain? What does it mean in IT infrastructure? What does it mean in development? And how to minimize threats and risks related to supply chain attacks? And how can we do it? So the model of threats and so on. So the question is to you, who is related to development as such? Good. What about infrastructure security? 50-50. The rest just came to have a good sleep. What is supply chain in real life? Why do we need it? How does it work in real life? For example, you need such a thing. What do you need to produce it? A wooden piece and an element, good hands as well. Of course, you need raw materials, wood, a simple chain. Now let's take a more complex one. You want to eat something, flour, yeast, water. Or what about raw materials? You see a tractor, machinery. If you think, it becomes more and more complicated. Now let's have a look here. You know how many problems are there in the cars. Something is fell off, you have to go, or the model is withdrawn from the market. And one of the vendors say that we have several layers, several tiers of supply chain. In IT, the situation is almost the same. The owners will be interested in how many elements do we have in this car, and they come from different vendors. All right, but this is not all. How does it work from the geographical point of view? Logistics. Red is one of the vendors, very well known producer of smartphones. Yellow, producers of jeans. And blue is for motor cars. This is in the COVID times. But now it's even more complicated because logistics is difficult nowadays. So you have a lot of vendors, complex logistics, and then responsibility of suppliers. IT, a bit of history. Security of the supply chain is not anything new. In your left top corner, you can see 2017, 2015 even, we started talking about it. Then loudly it was presented in SolarWinds. That is 2020. And of course, Log4j, which was also a supply chain problem in itself. Although it's open source, but we'll touch upon that later. It's not the end. Last year we saw a lot more things. Attacks against open source, against libraries, very popular, very well known, cloning of libraries. My colleagues made presentations and they talked about their researches at other conferences, at this conference as well. But in general, this is not the end. It will continue. The last research in April is shown here. Now, don't forget that it's not only the software that is affected. Maybe you don't know. Let me tell you, in your software, there is a module which is responsible for communication. It has firmware, and in a standard vendor cannot affect that firmware. What goes before BIOS, microprocessor, microcodes, and so on and so forth. Let us skip it. Don't forget about it when you talk about risks. But let's go on. Let's take an IT infrastructure. For example, a typical one. This is the landscape. Vendor 1, 2, 3, 4. You all know that. You have problems, and this is something you live with. Let us make it complicated. Data centers, companies, services, and so on. You have to manage it somehow and take risks. And finally, admins that are work on an outsourcing conditions. What are they doing? Outsourced administrators. So how can we mitigate it? Basic requirements: identification, authentication, antivirus protection, maybe certification and attestation. I take a solution that is certified by someone. It may help, but not always. And there are some metrics, foreign metrics, based on focused on a real manufacturing economy, not IT, but you can take some useful data from them as well. And the main thing that can help you affect your suppliers is the contract, typical contract. And you cannot change it much because the center tries to cut off its risks. And if you want to satisfy your IT security policy, you don't need a typical contract. You have to be ready to pay for that, but risks are risks. You cannot do anything about it. Let's move on. Supply chain for developed software. Software under development. Let's drill down a little bit to the specific software piece. A typical diagram for threat modeling. What can we see here? A certain solution, front end, back end, processes, files, vendors, storage, and open source. It's very difficult to realize any IT solutions without open source libraries or modules. And the question is like this. You can say, oh, let's delete open source, let us push the risks onto someone else. it doesn't work these days because you have a lot of open source, and open source has its own benefits. High speed, community to support. What kind of open source are you using? What are the risks involved? Libraries with 1-2 contributors are based on good people who contribute, who develop their product. If anything happens to them, you have all the risks of supporting the library. You have to support it, or you have to change it. Are there any security checks? What can we do about them? Continuous flow of SVE in open source libraries. What is SVE? Okay, good audience. What about support? What about supply chain? So how can we look at the real product with all those risks? This is the software that I showed you at previous slides. Open source is included in a certain product scope, and then if it has certain SVE, it can produce risks. You have to update all that. A bit of statistics. We started with Log4j because almost anyone was affected. PHP, for instance. You can see how many SVEs they have there, year by year. And this is myself when I analyze all that. Of course, everything is analyzed in an automatic way, but you have to manage it somehow, because without that, you cannot do. There are a lot of risks. Where can we see it in the development procedure? In these dependencies, which are part or which are included in your product or in the product of the vendor that you are using. They are there, for sure. 60, 70, 80% of the code of real vendors are open source. Produced, reproduced somehow, but still open source. You saw the figures and the list of threats coming from open source, vulnerabilities coming from open source. You cannot deal with them without automation. Composition, composite analysis. Well, we shall have more presentation about that issue. If you are interested, you can Google this phrase and you will see a lot of interesting things. Automation, automation, and automation again. There is one more risk. It's about the people who raised your hands. It's about development. It's a so-called shadow open source and how it can be revealed. When a developer doesn't want to enter the process or announce it, I'll just copy-paste it and continue and go on and on and on to production. When SVE is in the code that you copy-pasted, you will have the same SVE in the real product, and it can be very painful because nobody knows about it, nobody follows it, and you have to follow it. And you have to look for them in your product, because all of us are people, and you can have it somewhere. And the key thing here, it's for vendors. If you use open source in vanilla way, please don't believe that you can push your responsibility onto someone. If you accepted the code, you are the owner, even if you are not the author, but you have to know what is inside, what are the risks, and why is it this way and not any other, and you have to manage the risks. Let me add some more about proprietary libraries that you don't have the source code and you cannot even check it. 3 slides back, look at the contract. The contract, you get the library after that contract, and only then you have to use it, because otherwise you'll be alone facing the problem, which will shoot at you directly, and you will lose your functionality, your product, and the whole area of development, and people stopped trusting you. You lose your customers. So the acceptance phase is over. Now let's have a look at the threat model. The standards chain of development and product generation. What are the stages? You know the diagram. It's not anything new. You have a lot of frameworks in the internet. Below, in the low right corner, there is a link. We can draw it ourselves, but we just took it from somewhere. Developer, source code, build of the source code, package, and consumer. And you have problems at each and every step. Let's have a list of them. What can we tell you in general about the entire process? What do we have to trace? Basic IT security hygiene, standard requirements, formalized or non-formalized somewhere, but you have to trace it. Identification, authentication, logging, antivirus, everything related to that, servers, how they interact, role model, identification of resources. I realize that this slide is the plan of your operation 2 to 3 years ahead. If you start from scratch, to do all that, you will need a lot of resources, but I cannot skip it. Container security, of late, everyone talks about it. Kubernetes and others. We have security there, network security, secret hard coding. So a lot of CVEs there. This is absolutely necessary. Let us have a look at the threat modeling. Threat modeling, design development, design analysis. What exactly do we have to use in the process of development? Let's start from stage 1, tier 1. We have a person, we have his brain, he writes code. DevSecOps, we do not generate our own code, we use existing codes, Python, scripts, at the moment of tuning, at the moment of working with Active Directory. If you look at this model, and if in the build you are going to insert your critical resources like AD, post, mail, it's just a deviation. I'm going to talk about development more. Okay, we have a developer for infrastructure, DevOps, DevSecOps, a person who deals with code, with code changes, scripts, and so on. Let's ask questions to ourselves. If we describe any solutions here, they will be applicable to some people and not applicable to the other. But the answers will be applicable to you by all means. How and where does the programmer generate his code? He has a notebook, and and anything can happen to this code. Or he uses your enterprise hardware with all the policies inserted. Role model, what kind of code he can change or he cannot change. Is there a division of access rights to configs? Can a rank and file person change the config file? Are the access rights limitation rules good? How do you distribute access rights? There is one group which can do everything, the other which cannot do anything, or do you divide them by projects, by zones of responsibility? What kind of tools do your programmers use? Are all of them from the white list? Can you change them or replace them? Do we have an internal subscription mechanisms, signature mechanisms, additional checkups, blacklists for in your application controller? Who controls or reviews the code changes? Are there any senior people who watch the juniors? What will happen if the programmer will be forced to change a piece of code? How can you mitigate that kind of risk? Because, well, if someone is forced to do by external factors, he can do it. But will that commit be sent directly to the product, or will it be stopped in between? Next tier, next list of risks. How and where is your code stored? Who is going to replace it? Who can replace it? Who may replace it? There are pieces of infrastructure, the administrators who administer the servers, without source controller. He can enter something, inject something with his own hands. It may happen. Hosting servers, it's all right if you have SaaS. But is there any contract? Who is responsible? In the end, you are responsible. Who can change the access rights? Change the access rights and then change the code? How often and where do you take the tools, the updates of the code tools? Do you trust those tools? Deployer, we're going down to the infrastructure level, not the application level, but infrastructure level. What about access logging? If you have an incident, how can you realize what happened actually? Let's recall SolarWinds and how investigation took place. How many articles are there about what happened and how? Logging. Logging is very important. Let's talk about network a bit. From source controller to build, it's in between. What about network? Can we substitute traffic? We use TLS. How do you use TLS? Do you check the trust chain, TLS handshake, or any certificate will do? Think about it. It's important. In hardening of network security, there is such an item, and I want to stress it. What about build agents? How are they authorized in source control? We have TLS. What about logging and password? What about other types of authorization? What kind of code is taken for the build? Can it be substituted in full or in part? Certain branches only. This is the point to control. What about integrity? What about access rights? Agents are privileged for source control, and so on and so forth. And one more point, I thought a lot whether to use it or not, and used it. Are you downloading any kind of source code from wild internet? And who can prove that it doesn't happen? Now, build Active Directory. Let's assume it's Active Directory. How do you ensure integrity control of the build environment? What kind of modules are there? Are there any inserts which later can be exploited? What about integrity of the tools, compilers, packages, packers, unpackers, static analysis, anything that can be used in the build? Python, for instance, where 99% are using it. Are you sure that that interpreter, the exe file, is true? That there are no additional unauthorized commands there? Was there any access to the internet in the build? You can discuss with the developers. No. As soon as you get it, you have an upstream channel, the downstream channel, and slides with the history are about that point. If you don't have only the internal trusted repository, you cannot trust the channel. So trusted repository, where all the libraries are placed, checked libraries, verified libraries, analyzed libraries. Let me tell you more about the tools in the end. So check it by all means. Trust it. Check integrity. And what about the trust to artifacts in the end, at the output architects? Have you got the signatures required, the authorizations required? It depends on your policies, packaging and unpackaging, how you prepare the code that is going to be executed in your company or at your customer. Do you have this stage at all? Again, a few words about network. Do you trust the network? Why do you trust it, if you do? If it is not encrypted, TLS, not only encryption, but also trust to the point-to-point communications. What kind of checks the modules undergo before packaging? Can you trust them? At the build stage, that code goes somewhere. At the package stage, it should be rechecked again, because it may go through the channels that you do not trust. What about integrity of the repackaging tools, signatures of the packages, trust to output artifacts? We almost reached the end of the chain. And what can the user check? Because in the end, he will see the package. At the infrastructure level, it will be the final script of build unpackage and its installation onto application server in the application infrastructure. It's the target infrastructure where the code is going to be executed. And you have to trust that code. There is no other way. Here, you have to check it, whether it can be trusted. And the final point is about delivery of the package
Can you check the channel of delivery? Is this a trusted channel? How does the user get the package? As we are aware, we can download the package and check the hash, or if we have a hardened channel with inspection of all the certificates, etc. What's with TLS and what's with the certificates? And again, it's about a hardening of the channel. If you use certificates, they have to be inspected. CRL, I think that everyone heard about it, that's in TLS. So whether actually the CRL is inspected, do we use CDN for workload distribution, and can you trust your CDN? And the answer is more often no than yes. So you've got to think, if you deliver your product through a CDN, you want to think about some additional checks and inspections of the product, and this brings us back to signatures. How is user support organized? How would our company respond to questions from users such as, well, something is not working and we don't know what it is? Do you use any additional content, something that marketing likes? We want to show an additional picture and, it doesn't affect anything. We don't want to check it. We won't put it in TLS. We won't put any signature on it. Let's just do it quickly because we want to run an ad in mobile phones. That happens quite often. And if you don't check it, if you don't inspect it, you might want to think, if your code parses this picture, can your product fail here? And then again, can any code be executed, God forbid, in your name? And finally, DDoS. We've got to think that the availability of all of this has to be at a high level. Okay, and finally, our ill-fated consumer, for whom we work. We do all this work, after all. That is the point where profit is written. And the user should be able to complain and, importantly, get a response. Okay, your software doesn't work. And the response would be, you've got to do this and that. And if your support function works well, they would provide feedback to development that, look, you've done the installer in such a way that no user, let alone an old grandma, can install what you have developed. That's a different story. That's not quite about security, but still, feedback has got to be there. Okay, and what is happening globally? For example, I say that I've got a really good infrastructure, and how can I prove it? And the answer is that directly there's hardly anything that you can use to prove. In Europe, there's a framework being developed, not approved yet, in development so far. On all those checks and inspections, it's still in a draft state, and this would probably be the nearest thing to being able to prove it. We have been through ISO 27001 SOC 2 audit. And if we were to try and do an audit for the sake of a paper opinion, you can easily go through it. We did it for ourselves, so that not just us, but the auditors also looked at what we had, and we asked them to ask specific questions. That's quite useful, but again, that's not a bulletproof guarantee. The new framework that is being developed might be better. And regular reviews of the security of your system, and regular is the word, because changes happen very quickly. We are the supplier of standards for the infrastructure in our company. So you've got to have regular audits, you've got to have a team that would be very much on the alert about it. Otherwise, you might not end up with a good thing. And the more automation, the better. This sounds like a banal thing, but still, the more infrastructure you have, the more sophisticated it becomes, the less it would be possible for you to do things manually. Okay, further reading. I especially recommend the first link.
DevSecOps guideline.
DevSecOps guideline is quite good. SLSA. That's the picture that I think I showed to you about 10 times during my presentation. There's a lot of information there. CI/CD top 10 security risks. It's a good thing to rely on. A few words about OSS feed. Which libraries are good, which are not good. That is about a repository and what to use to check that repository for your own feeds. So that we were able to use our own expertise, and we have our own expertise in the form of a feed, and you are welcome to Google that. Okay, and please, once again, can you please rate this presentation? It's important for the conference to have this rating, and the same QR code will appear after every presentation. Thank you, that's really very important. Okay, and I will be looking forward for your questions now. Again, there's another QR code here. Okay, and for the bad questions, we'll take away your arm. For the good questions, we'll give you a prize. Okay. We have the first person with the microphone. Yes, thank you. Thank you for the presentation. Going back to business supply chain at the development stage, going back to the very first parts of your charts. What if our developer doesn't have any bad ideas and doesn't want to include any malicious, but they are a front-end developer and they have a front-end app with thousands of dependencies and with a lot of nesting? So how do we check and inspect all of that? Thank you. The short answer is SPOM, something like that. You're welcome to Google the abbreviation. That is the list of all dependencies, which ideally is generated automatically to reduce the human factor that you were referring to. And then checks and inspections and checks and inspections again. I guess you were talking about NPM, but NPM creates this tree of dependencies in an automated way. But you've got to inspect everything. You will be surprised if you try to update that in an automatic or non-automatic mode, how much work there has to be done there. And if you ask, then most probably you haven't done it previously. That is quite dangerous. NPM tabs. Last time, yeah, there was NPM exploits were a serious problem last year, and the face was the easiest problem that you could have, although in certain applications that is quite dangerous, or there could be credential stealing, etc. Okay, please remember to use a microphone, and I have a lot of hands on this side of the room as well. Yes, hi, thank you for the presentation. Clearly, millions of vulnerabilities can be found, but how do we identify the surface of the attack? What do we patch? And where there are vulnerabilities, even critical, that can be postponed. Thank you. I can't give you a direct answer right now. Let's have a chat offline, because we've got to talk about your pipelines, about your technology stacks, and about your languages. A general answer is yes, that is painful. That is a whole process that you have to be mindful about. And not just that, you've got to really do it. Okay, let me share my experience. It starts with prohibiting everything that the checker during security check responds. It's not just CVE vulnerabilities, it's also supply chain vulnerabilities that I talked about. I'm lucky to have right by my side people who deal with that, the researchers who find those vulnerabilities. But in general, there are public feeds of various quality, but still. So you want to use those. And then question becomes what you do with that, depending on the frequency of your releases, depending on what has been found. You either patch everything and run after the most recent version, but also to understand that 2 weeks after your most recent release, you might have a vulnerability. But here, there's the second stage, which is the assessment of applicability. And that is to have a team that he would be able to say this is applicable and that one is not. That is quite a difficult stage. I try to give you a high-level answer, and I'm happy to take this offline to discuss your specific solutions. Good afternoon. Thank you for the presentation. You mentioned Sarah open source, and that there's a library that has been copied and reused. Okay, we'll consider it as our own code, and we would use static analysis, code review. But do you know, is there any way to determine that there's a library that has been copied from an open source, widely available repository? Answer: well, it's not code review. Robots and machines should be doing this job. And again, the more specific approaches, I guess I can share offline, because I don't think that would be of interest for the whole room. But the high-level answer is that, yes, there are approaches. Yes, there would be some false positives because you work with code. But in general, this can be detected, and the outcomes are quite good, especially as you look at the legacy codes. In general, yes, you've got to be mindful of that. There are algorithms to look for and find similarities. Next question. Thank you for the presentation. Very exciting. You talked about CVEs, that we have vulnerabilities that can end up in the code. Does it make sense to distinguish between CVEs as vulnerabilities and backdoors that can find their way in the code, whether voluntarily or not? Can we use static or dynamic analysis to address that? Well, the last phrase, what was a little bit confusing. I'll respond to your question before that phrase. The general answer is yes, there's always a risk. A standard CVE describes a flaw or other vulnerability. Backdoors and exploits might be doing something bad, and not even to your code, but to the environment. That could be stealing credentials. In our research, there was a slide last year that I want to describe now. Apologies for dwelling on this for a little longer. One of the less fortunate researchers copied the package to NPM and changed the title, but in the comments they wrote, "I don't want to do anything bad. It does the same as the other package, but I want to get paid for it." And they gave a link to a bounty program of the vendor. So this is where it might end up. Or they could be stealing credentials that they can get hold on. Okay, that is the supply chain side of things, and CVEs are CVEs. You can respond to them in different ways, but another policy could be that if you get alert on a particular library, that this library shouldn't be used. That depends on your policy. Regarding SAST and DAST, it depends on the tools. Such tools can alerts to CVEs, but the question is how you find it, whether false positive or true positive. And to follow up on the question, should we be looking for backdoors at the stage of development or rather later in the pipeline? Answer. Well, the classic approach would be if you can detect it in the code phase, you'd better do it there. That's complementary. And so the diagram that I was showing you consists of a number of parts for a reason. For every part, there is a certain set of checks and inspections would work. And detection at every particular phase depends on the tool. I'm deliberately tool agnostic because stacks would determine technology. We have our checks at almost every phase, and then at the end we have yet another check and screening. Next question, please. Please pass the microphone here, because the guys are tired of waiting. Okay, thank you. My question is this. Wouldn't the product delivery fail at the end user because of how your product is structured? If the user doesn't want to do any checks, so does it make sense to do this pipeline at all? Answer. There are users who don't want to do checks, and there are others who want to do checks. Those who don't want to do that, we can't replace their head with ours, their brain with ours. And in general, we have to accept that there are users who are such, and there are users who are different. There are others who want to do checks. They care about their security. They are quite serious ones. They write long articles explaining that this is very important. Well, for ourselves, we have products that work with low-level drivers. So if something happens there, then you could crash the whole system. If you have an easier solution, if you have a simple calculator, then it's perhaps not that important. But again, what can it do? For example, here's a file with passwords. You don't have the file with passwords, do you? Good for you. Okay, so the general answer would be yes, you'd be better off to do it, and then it depends on your case. Thank you for the presentation. Very interesting. Highlighted a lot of important points. Question: how would this pipeline that you showed change if we do delivery to internal users? Say we are a product company and we deploy within our own company. Okay, I think I understand the question. Is there anything else? Fine. Depends on your security policy. You're asking the question now, I think, from the developer's point of view. What if you ask your cybersecurity? Do you want us to build in more security? And they would say yes. So you're welcome to do that. Unless you sit isolated from them, you don't talk. But if you think about it, you might be starting to ask questions. Have you, or are you checking the code that you compiled over there? And the answer would be no, because we don't have the resources, etc. And then you end up with risks. Ask yourself a question, whether you need it or not, whether it's needed or not. How much money might a company lose, and how difficult consequences you personally might have if such happens. SolarWinds, I don't know how people were able to stay alive after what happened, but it depends. Okay, to follow up. So whose responsibility is it? Is it the responsibility of development or the writers who write manuals for the product? Or maybe it's a problem of not enough rules in the pipeline? Answer. Okay, it's a role model. There are roles that are responsible for every step. And when the responsibility is not clear, it's not good. There should be incident review. And if the problem was on your side, it is you who should be held accountable. But there are individual teams who are responsible for individuals who are responsible for particular areas, and then you can create roles and assign risks to the roles. Otherwise, if you say, look, John, it was your fault and they can't do anything because they don't understand what's going on, and anyway, it's not their responsibility. Yes, hi, thank you for the presentation. Very interesting one. I can't resist, because you're from Kaspersky, to ask, do you consider checking dependencies through an antivirus if the exploit is in the dependency itself? The scanners that we use, for example, don't inspect the code if it has been coded or decoded in a number of ways. And sometimes it makes sense to add into the pipeline an antivirus check that would scan the logic and perhaps find some malware traces. Thank you. An excellent question. That's a top question. I'm confident you are getting the merge. That is the prize. I want to address this in two stages. Stage one, do you want to inspect? Yes. The question is, at what stage and how? And the key thing, what do we now mean by an exploit? This is not a CVE, is it? We are talking about some logic that might be harmful. Responding for myself, yes. If I were to respond, can we cover it 100%? Then probably no. But I guess all the technology that can be used to defend and detect, the question was about me, was it? We use that, we use all of that. And the final scanning at the very end happens both dynamically and in sandboxes. Of course, we do all of that. Responding to the question, the other part of the question, we understand that we've got to test our technologies, and we did the tests, and yes, it works. Good afternoon. My question is not on the technical, but the organizational side of things. Okay, so suppose we have covered the internal team with controls, with security and scanning, etc. But what do we do with the outsource that the company employs for development? How do you get into the pipelines of a team that we take as outstaffers and similar arrangements? Again, we understand that what we developed is secure. What about the thing that those guys bring? And I have a question. I want to turn this question on you. Who is the real producer of your product? Is that you? Yes. Okay, so everything is your responsibility then. And the next question that you asked is actually a different question. How you control all those people who work with me, who bring pieces of the code, etc. And the answer is, first, a contract. They should be accountable, and I understand that, you know, enforcing that accountability is a different thing with outsourcers and outstaffers. We know how outsourcers work. So it would be difficult or very expensive to enforce, but all of those checks and inspections should be on your level. If you don't trust your outsourced, outstaffed coders, it's a big problem. What do you do to trust them? You want to trust your code, not your coders. Okay, and I guess that now we have to be wrapping up, really. Those who still have questions, let's just agree that once I step off the stage, I will be over there. Please try to catch me there. I'll try to take all of your questions. Thank you once again. Thank you for the Gleaming Eyes. The merch is over there. Yes, and the prize I will give to that gentleman over there and to you as well, because you answered the right question. You asked the right question. So please approach us here. One there at the back, and one 5 meters from the camera in the back. Okay, and now I'm stepping off the stage. It seems that I've overused all the time possibly conceivable. Thank you very much. You're an excellent.